Good morning, everyone. So what we're going to be doing today is we're going to be continuing on with our lesson from yesterday. And remember that yesterday what we were doing is we were solving for a variable, which is also called isolating a variable. Rather than trying to get a single number for an answer, what we're doing is we're trying to basically rewrite a formula so that one of these letters or variables is by itself instead of what's already by itself in the equation. And we'll talk about where this comes into play, like why this is useful in a little bit. First, let's just remember the process that we have here. Remember that when we're trying to move things from one side of the equation to the other, what we're essentially doing is trying to reverse whatever is done to it. So in order to move things away from one of the variables, which in this case we're going to be solving for z, we're going to isolate z, what you're going to have to do is undo the order of operations around it. So let's just get a reminder as to what order of operations is. We're going to start with any grouping symbols normally when we're simplifying, right? We then move on to exponents. We deal with multiplication and division from left to right. And last but not least, we'd deal with addition and subtraction from left to right. And remember, this tells us how to simplify math problems. But if we're trying to solve, what we're going to be doing to solve is we're going to be reversing that. We're going to undo everything that's normally done so that you can see what that original number was. So that means I'm going to start by getting rid of or eliminating any addition and subtraction around the z. So any addition and subtraction really just applies to this 2x because that was added to the 3z term. So I want to subtract or undo that addition of 2x, and I'll subtract that 2x from both sides. Now this gives me an answer so far of 3z is equal to m minus 2x. And in this case, since both of them have variables, it doesn't really matter which ones you put first. Just go ahead and write it in the order that it's in. Make sure that that negative stays with that 2x. It does not belong with the m, right? Because it's right in front of that 2x. Well, now that I've taken care of all the addition and subtraction around that z, the term that I'm trying to isolate, I'm going to deal with multiplication and division. So let's divide this by 3 to undo the multiplication that's in front of it. And I'll also divide the other side by 3. This is going to give me z on its own on the left, and on the right I'm going to have this 3 dividing both terms. Don't forget that little heart appears as soon as you have an addition or subtraction sign with that division over here. So what this is m over 3, which we can write as m over 3, or we can do 1/3 m, taking the 1 that's kind of hidden in front of that m and putting it into the fraction. And then this is going to be minus, because we do have that subtraction sign in front of the 2x, minus, well, this is going to be 2/3 x. And again, remember it's okay to move that x down to the side so that you've got this coefficient, this lovely number all by itself in front. Now this gives me my final answer, and I would be done with my problem at this point. What I want you to do is pause the video now and try this problem. I'm going to show you how to do it in just a moment, but go ahead and attempt it on your own first. Let's see how it's done. So what you should have done when you were solving this, for x, that was my fault. So we want to solve this for x, is start by making sure you're going to keep everything balanced. And remember that I'm trying to isolate x. Now I'm going to circle x because it helps me stay focused. This is the one that I want all by itself. And I have to get rid of addition and subtraction first as I undo the order of operations. So I'm going to get rid of that 4 by subtracting 4 from both sides. This gives me 3x on the left, and on the right I have y minus 4. Here, I divide both sides by 3 to undo all of the multiplication and division around the x. That leaves me with just x on the left, which is exactly what I wanted. And on the right, notice how I have to do the little heart thing again. This is going to give me 1/3 y, or y over 3, minus 4/3. which, by the way, if you wrote 4/3 as 1.3 repeating or 1 1/3, that is also correct. Don't forget, you do need a subtraction sign in front of that 4/3. Let's try then a different sort of problem. Let's say that we had the problem 3tz is equal to y, and I wanted to isolate z, so that z was all by itself on this side of the equation. Well, how do I do that? Think about your order of operations. You want to undo it in reverse order. So I want to undo addition and subtraction first. And you go, well, Miss Prenz, it's kind of stinking hard because there is no addition or subtraction. Well, that means you just don't need to do it because you've already finished that step. There is no addition or subtraction to move away. But we do have multiplication and division. So that's what I'm going to look at here. Currently, I have z times 3 times t, right? And I want to move those over. Now, you can do this in 2 steps, eliminating one at a time. But think about it this way. 3 times t is just a number. So why not divide the 3t all at once? And again, watch that you think of this in terms of parentheses. So here, notice how the 3 cancels out because we have no addition or subtraction, so we don't have to do that little heart thing. They just cancel each other out. Same thing with the t, it's going to cancel out, and that leaves us with just the z. On the other side, we're left with y over 3t, and there's nothing here that cancels out or simplifies, so that would be my final answer, and I'd have what z equals. Now, in another example, we can do this again, and this time let's start with the problem 2 times m times t is equal to q. Now when I do this, again, let's say I'm solving for one of these. I want to get m by itself. Now this one is a little bit harder because you want to get rid of both the 2 and the t at the same time, right? Because we would really like to get that m by itself. And I know that the only thing going on here is multiplication. Since the only thing going on here is multiplication, remember that I can write this in any order that I want. So I could rearrange this to 2t, just moving the t in front of the m, times m. And that will give me the exact same answer. I'm allowed to rearrange multiplication. That means that when I'm trying to eliminate that 2t, I can just divide by 2t, and that will get me my m by itself. So I end up with m is equal to q over 2t. And that would be the end of the problem. So what we're going to do is we're going to stop here for today. I have 2 problems that I want you to do in Turn-In on Classroom. The first is going to be similar to our first set of problems, the second to the second. I'll have what variable to solve for as well. Here you go. Please make sure that when you turn these in, all of your work is shown just like it was shown in the notes. At this point, we still do not know how to check our answers, but I'll be showing you that in the next video. Have a great day.